Ready? Okay. Then welcome to the next talk. I just have the short name here, Fabrizio Manfredi, but there's a Furo Holman. Yeah, that's my last name. Okay, so we don't have it until now, but now we know it for the next time. So thanks for coming. You're talking about data replication. I'm really happy because it sounds a big field. Yeah, it's a big field, and I'm a little bit worried because could be good for someone, probably not good for other. Then I see not many people. Please stop me, ask me question. No, is this not enough deep, or is too deep, or anyway? So I think we can make a more interaction section. Okay, perfect. We look forward to it. Then it's your stage. Thank you. Oh, okay. Can I ask you why you are interested in data replication in this session? Quite to have any idea what is the topic that you want to know. Just for fun. Yeah, that is fun. I have to say that is fun. Yeah. There are many situations where we have more than one node. And we have to work on the same data. There are many situations with more than one node, and you need to replicate the data across all the nodes, I believe. Yeah. Well, this session is divided mainly in two big parts. The first part is an introduction, and probably a little bit boring, with some theorems, some common patterns, some algorithm, and so on. And after that, when we will know the algorithm, we will try to understand how it works in different implementation, like file system, database, NoSQL, and some common tools. Data replication, we already a little bit anticipate, is a big topic. In the past, was mainly connected to snapshot or backup, disaster recovery. But today is more connected to cloud computing, scalability, availability, high performance, distribution around the world. Because today, you can have one data center everywhere. You can buy, it's quite a low price, some VM somewhere. First example is Amazon, and you can have one VM in Sydney, one VM in Singapore, one in Sao Paulo, or Santa Clara, and so on. But, well, the world is quite well connected. If you check the wire or undersea wire and so on, there are a lot of connections around the world, but probably not many people know that you need at least 200 milliseconds between Sydney and Santa Clara, or 250 milliseconds from London to Singapore, and so on and so on. That seems very small amount of time. We're talking about milliseconds, but probably you already know much better than me, the latency on a single packet is a really killer application, or kill your application. Because we can see when you arrive to 200 milliseconds, your response time is close to 1, 2, 3 seconds, depending on the size. That means the bandwidth is not enough. The bandwidth is important. The bandwidth is very important in the local data center. But when you have more than one data center, you have to fight with the latency. Some other measure to understand the difference that you have in memory and network. That in memory, you talk about microsecond. In network, you talk about millisecond. Then any operation, any transaction in memory is 1,000 faster than any other solution. And for the latency, in 2009, I believe, Brewers defined a CAP theorem, defined 3 main areas of interest. Everyone wants availability, partition tolerance, and consistency. And they said it's not possible to have all together if you use a network mainly. If you don't use a network and you have a single installation, well, in the past, 20 years ago, that was quite famous, the tandem system with double hardware or triple hardware. No, that's high availability inside of the hardware. But if you don't have more than hardware, you don't have availability. But if you want availability, you need some connection. That means you introduce some latency. Then 2012, this theorem was a little bit reviewed, but the concept remained the same. Today, we talk that you can have the three elements together in the same time. You can decide time by time what you want. To break a little bit the paradigm of ACID, the database, to have the consistent and so on, we have seen the NoSQL generated a new topic, the base availability, soft state, and eventual consistency. But mainly, the main problem that you have today that client can see different stuff in the same time. And it's quite funny, they decide ACID and base, like in the chemistry, that you have complete two opposite view, or also two opposite reaction. The CAP theorem, what you want to use, if you want to have more availability or consistency or partition resistant, is not a technical problem. It's mainly a business decision. You have to decide and to talk with your business or your stakeholder to be agreed, because it has a big impact on the business. Now we will start a little bit with some formula, and but yeah, don't worry. We have seen we can divide the problem in more or less 4 elements: data placement, data consistency, system coordination, and data transmission. This is more or less the 4 main topics in data replication. First of all, we have seen latency. If you want to transfer with a single piece in a long distance, but also in a local network, will take a lot of time, because TCP and so on and so on. That the first topic is to divide your content, your block, your data, depends, or no, that you can base on the byte, can base on the feature, can base on the topics. Up to you, but you have to divide. If you divide, you can use multi-stream, that means parallel operation, and also the multi-core. Otherwise, you have only a single operation. When you have divided your component or your information in small elements, you have to decide how you want to deploy, how you want to place. Mainly, there are 3 topics today. One is centralized, that you have someone that knows where is all the pieces of your information, or completely decentralized, that you have some mathematical formula that is able to look up for you or give you the information where to pick up where is the information based on the content we will see. There is also today a cross on the 2 that is more distributed. No, that's not try to make more advantage on the previous 2 elements. Today, the more used or more you can find everywhere, I have to say, is a placement by hash, made hashing. That seems complicated. No, that's, if you see that, seems that is written in another language. But the concept is extremely simple. You have your data. You divide your data. You made the hash that you want. And after that, you have to define, in most of the case, virtual node. The virtual node is a range of the key. No, if you use, for example, SSH1, you have 161, I believe, bits that you can create a range of key. You divide this space in element. You can call this element vnode or as you want, and assign this vnode to a real node, a real server. And immediately you have distributed your data. Another important that to visualize, you can put the key in a ring, and then you can understand how it works. That's quite simple. And this approach is used mainly in all NoSQL, but also in the cluster and replication. There are some theories, some other algorithms that are based on the space evaluation, or multi-dimensional, but at the moment is not so used. But it's quite interesting. Okay, now we have found how to distribute the element. The second point is how to make the replication. Now, we found that to send one piece in one node, that is not replication, this is only placement. How can do quite easily and without problem? Mainly today, you can find two approaches. One approach, very simple, to send the key that is in your range to other two elements, other two nodes that are close to you. That's very simple. You receive the key, and you send this. You receive the piece of data, and you send to the element. The next two, the previous, and the next, as you want. That means you have, and for this reason, most of the time you see the replication is based by 3. Well, also for other reasons. The second approach is to create on the node level a small cluster of 3 elements. That in this case means you need coordination, election, and many other stuff. The first one that I said is quite simple. The second is a little bit more complicated, but it's faster to detect the failure. Any question? Simple, I believe. No? Yes? No? That is more simple. And we have seen in NoSQL, or anyway, the new approach is to reduce the consistency. To avoid the consistency, or well, to introduce the consistency when you need, today we are more or less 6 ways to make something similar to Paxos, or anyway, the commit that we have in the database. This is the last one. Is more or less what happened in the database. No, you lock everything, you write everything, and you unlock. How you can reproduce this situation if you don't have any locking system? You can write and read more than one. Well, that means a simple example is read all write quorum. If you have 4 nodes and you write you start to write, that you have to write on all the nodes. But you read always 3 times. You know that if the data is there or not. That is a simple approach that is used to create a kind of guarantee. Or otherwise, you can create a quorum, and there are some other approach. Basically, you start from the first picture on the top that you can recognize immediately. That is more or less what happened, like in the MySQL master-slave, that you start to write, but the information probably is still not on the slave. If you increase the number of the read on the slave level, you can create like a read all, write once, or write all, depends. But what I want to say that there are some techniques that you can use to make a simulation of the commit when it's strictly needed, when you want to be completely sure that the data is committed and is stored on the device. That's any question? I have to explain a little bit more. No. For this reason, it was nice to the whiteboard. We have said, no, we have in some cases small cluster, and we need a coordination. Today, we can see 2 main protocols. One is the Paxos, that's you can find implementation everywhere, and is an election system. It's a consensus and election system. Quite, I don't want to say quite simple, because it's not so simple, but it's quite clear. Today, also from NoSQL or emergent technology, we have epidemic. Well, sometimes you can find gossip. The epidemic protocol is an idea like the virus, to contact one other node and exchange information. It's a kind of build a routing table. You exchange information with another node, and you, after a couple of interaction, all the node in the cluster has the same information. You can see that, well, it's based on log n, and you can see, after a couple of interaction, all the elements in the cluster have the same information. Also, in this case, you can find many types of implementation, but yeah, in the beginning seems strange, but it works. And in most of the cases, more faster than consensus that need all the parts are agree with a specific value and collect information and elect a new master. The consensus protocol is used mainly in the database for two-phase commit. The epidemic protocol is more used for failure detection. On the transmission protocol, well, if you know how the cell is divided itself or reproduces itself, you can know there is some phases. And one of the first phases is to put some order inside. Also, the replication is quite good to, first of all, reorder, because sometimes the data is, you have two operations on the same block or two operations on the same data information that doesn't make sense to transmit if you have a buffer, but that means you are not synchronous. You have also compress and more data, that means a better compression. And you have also you can transmit by difference that doesn't, if you have the data and only a small part is changed, you don't have to transmit all the data. But that means you have to keep the hash of each single element. But the hash of each single element, in most of the case, if you use hash placement, you have, because it's a hash base, and the hash could be the content of your element. That you have all the hash, you can compare the hash and transmit on the block that is changed. That is quite simple and obviously quite fast. There is also some other optimization, like Merkle tree. Merkle tree is a way to rebuild copy that is broken or went offline. It's always based on the hash. With the hash, you can save a lot of time, and as we know, the latency kills the transmission. That less data, less latency, mainly on the real data. There are many other things, like locking, with distributed locking, multi-versioning, and so on, but I decide to skip this part. OK. Now we know more or less how it works, the replication. We can see the tree element, the cap theorem, and we can see the availability consistency is mainly based on RMDBMS by database, relation database. We have consistency and partitioning tolerance. We can have MongoDB, HBase, and through availability and partition tolerance, we have RIA, Cassandra, and so on. This is mainly the implementation based on the algorithm that we have seen. Sorry. We can also divide the content. That's another important topic. I want to say, doesn't exist a perfect replication system. The replication system is made based on the content that you have. And obviously, if you have to replicate block or file, probably the best solution is a distributed file system, because probably you don't want to lose data, or you don't want the user to see different data, and so on. Or you don't want overlapping or inconsistent state. If you have information that you can, is well structured, probably you want a database. For most of the other things, document, blocks, section, properties, or content that doesn't change very well, you can probably want to move to NoSQL. Now I will start to see a little bit the implementation. The first is distributed file system. That is a strange is a strange animal because seem old, but at the same time, we have a file system everywhere. There are tons of file systems, distributed file systems. There are someone are more famous, while Samba CTDB is not really a file system, and also DRDB is not a real file system, but you can find on the internet a lot of solution open source based and many other solution proprietary based and quite expensive. The main advantage of file system is a file system that everyone read and write file. Then you can automate operation through a bash to Java and whatever you want. And you don't have to care about the localization of your data. You read and write. Most of this file system has a single unit path. Then the path is the same on all nodes. The disadvantage in most of the case, they have problem on scalability or high availability, depends on the implementation, or also partition tolerance. That depends if the file system was designed to be fast or to be more consistent, and so on. The first, and probably you know very well, is DRDB. DRDB is a block replication, doesn't have a high scalability. It's very good, very fast, but is more oriented on a single service or to help the database to scale and high availability. The other big advantage of DRDB is to make a remote copy, and that's probably is a good solution for a disaster recovery site. But no scalability. You make a replication of single disk. It's like to have an hardware that is able to make a RAID 1. More interesting, I think this morning you have seen the Ceph. Today the Ceph is de facto the storage for cloud, for virtualization system. Is very well designed. Is use some technique placement like based on hash. Is consistent, has a strong consistent, but also now start to move on weak consistent to afford problem on geo-replication or long distance connection and so on. And we can see the has, as I said, hash base, has a Raft is a simplified Paxos protocol to make an election and coordination of commit, and probably you know better because you have seen this morning. And they start to deploy, like CERN was deployed with 3 petabytes of data. And if I remember, there are close to 8,000 VM running there. They start to think to replace completely also for collect the data of the experiment, because now is the backend, as I said, is de facto is the backend of OpenStack and so on. But they start to thinking to migrate also other projects that are more and more has more and more data. I believe 30 or more petabytes of data. One of the implementation that's quite, you can understand that you can use Ceph as a replication system to work directly to Rados on OSD level is done by Okeanos, is open virtualization provider. They have set up a solution and they use Ceph or mainly OSD to make the snapshot replication of the AMI and start up. And they, at the moment, has a good success. You can see they have more than 5,000 users, and they started more than 250,000 VM. Any question on the file system you want? Another solution that is not in the slide is OpenFS, that is more related on content base and cache on the client side. Now they restarted to develop. They are quite interesting development. And the big advantage is the cache side on the client. Then reduce the transmission based on the persistent cache that you have, and the notification, the callback. You work on your local data, and if someone made the change, you receive a notification. That's to avoid data transfer or pooling and so on. But keep the consistent of the data. That's quite interesting. They have also a read-only copy. This is more a snapshot that you can duplicate volume on the fly, or reelect one volume master to another VM. No question? Okay. Well, probably today, one of the things that doesn't skate at all is the database. Well, the database has a big constraint, have to be consistent. Then it's quite difficult to scale. If you have done some simulation on, for example, Postgres to sync replication with a hot standby, probably you have seen that the performance immediately is cut by 50% or more for the network latency, for receive the knowledge on the other side. Then if you want to be consistent, you don't have solution at the moment. It's not possible. Or better, it's not possible to have a good scalability and to read the same data everywhere. That means you can use, in most of the case, many nodes on the master level. That means you can scale if you want to keep, you don't scale very well if you want to keep the consistency of the data. And mainly the high availability is based on 2 nodes because you have problem. The 2 main software, well, the 2 main database that you have today on the market are, MySQL or MariaDB. That probably in the future will be more MariaDB and Postgres. They use 2 different approach because MySQL is more asynchronous on the replication, that you can connect a lot of slave. And this is a big advantage because you scale, but as I said, you don't have any insurance, you don't have any guarantee that the slave is up to date. I think a couple of years ago, they introduced async replication, but pay attention. Async means that one of the slave send a knowledge, not all the slave. Complete different story for Postgres. You can use the synchronous, but as said, you kill completely the performance. That seems no solution. Well, you can use some external tool like Tungsten to make the replication that increase a lot the condition. Or I didn't see many installation MySQL cluster that is main memory based. No, you have a lot of limitation, but it's multi-master. And I've seen some installation with more than 1 cluster connected in a ring in a different data center. The main topic is you can write some content and read to another way. No, you use the MySQL. I've seen someone that tried to use the database as a bus of communication to propagate the information across the data center. For all these problems, no, they started, most of the people try to start or to try to find an alternatives. And mainly we know these alternatives like NoSQL, but yeah, each alternative has a specific range, a specific topic to solve. And well, probably you can find everywhere, no, you have key-based or column store or document-oriented or graph-oriented. Because if you do one single thing, you can do these things very, very well. And on the performance side, we have seen quite incredible things. For example, a couple of, I think last year, the VoltDB was able to reach 1 million transactions per second. But obviously, that is simple if you keep in memory. We have seen the memory is 1 microsecond. But anyway, that is a great number. Also Redis, and that today Redis has a multi-master implementation, is still beta, but also Redis is able to handle 1,200 transaction with 60,000 clients. You can understand immediately why most of the people start to use NoSQL, because this number probably you are not able to handle in the database, but obviously it's a simple operation, get, put a single data. And yeah, there is Cassandra, React, and so on. I will talk a little bit on React because, well, I like, but I think it's a more example for what we have seen. React, like Cassandra, is inspired by DynamoDB and is based on hash with the ring and has geo-replication. That's quite interesting. And as I said, you can define, when you write the data, the consistent model that you want. If you want to write 3 replication and want that the node that wrote, the proxy that wrote for you, return only when 3 was written and 2 is read to close the connection or the commit. Then, for example, in this way, you can, for a session, to use 1 read and 1 write, but for billing data, you can use 3 write and 3 read. Not to want to be completely sure that the data is there, or otherwise you make a fault. That is nice because you can define your level of security that you want from the data, for the persistence of the data. Yes?
And then it's valid for all.
You can specify for a single key. It's not a session level or no. You can say, okay, put this value, but I want the security of 3 elements. And I have, yeah, that's mainly. And that, yes, this is something, that's both, we can see in both directions. The database now try to use as a backend NoSQL for some operation, but we see also NoSQL try to be a little bit more consistent. And as I said, now the model of the cap, okay, you can have the 3 elements together, but I can design time by time, well, when I made the operation, which I want to use. What I want to be more consistent, that I can be slower. I want to be faster. And yeah, today there is also another trend, but without many success, probably, I don't know, it makes sense. Build a file system on the top on NoSQL. There is, yes, 2 main approach. One Fuse, that is slow and in most of the case not well maintained. And on the other hand, export the S3 interface, compatible interface like Amazon S3. And this, because also in this case, S3 is more or less de facto the interface of the storage or the object storage. I've seen on React has a specific application called CS. With 3 nodes, you are able to run close to 100 megabytes per second. And yeah, the advantage, you can store the node where you want in different data center and not in different region. In different regions is always a little bit a pain. Also Ceph sometimes, in case of Ceph, sometimes it's nice to use the pool cache, and use the weak consistent, otherwise it's too slow. Yeah, some you can find a lot of implementation example. I pick up one of Voga. They have 50 million keys. They have 50,000 new per day, and we have 10 million per day of update. And yes, they don't have so much, but they have 200,000 requests per minute. Something similar was made by New York Times. They decide to use Cassandra. Mainly they decide because the support of multi-region is free. In the React, the multi-region you have to pay. And they use the Cassandra kind of a bus to push the information to mobile customer if there is no news and so on. And they have 2 main installation, one Europe and one in US, based on Amazon region, and you can find some other details on the FOSDEM of February of this year. What I want to say, okay, sometimes we have seen that you have specialized topic derived by specialized software, then In many cases, you have more than one solution, or better, you have to put more than one solution together. And that means layer. Well, you have to pay attention about that, because yes, you reduce a lot of number of their requests, then probably you can use less VM, because you each layer intercept and has a hit ratio and so on. But on the other hand, you increase the latency. If you are a web-oriented application, no, that's quite good. If you are more read-only, it's quite good. If you are read-write, you have probably to find some shortcut to go directly to the origin and so on. Or, yeah, that's some example is, I don't know if you see eBay. No, that's eBay. I don't remember if until 5 minutes you have kind of static page, or is a refresh every 30 seconds or every minute. But when you are close, below to 5 minutes is updated, and the refresh of the page, you are redirect probably on the node that has the master of the information. That's the main topic is you have to be close to computation and calculation, and yeah, try to move the master more close where the write activity happen. Because, well, it could be the read is not important, but the write and write could be more important. There is some algorithm on the locking and election that can move the master of the information. If you want, you can build your replication system. It's not complicated, but, well, I'm not sure is really needed. And we have seen that you can use NoSQL to do that, to replicate some information across the data center. You can use file system. And yes, everything works quite well. I've seen most of the people use that. You really need real-time data. If you don't, probably are seeing there is some improvement. I've seen some improvement around that are able to increase the number of the thread, use more cores, and so on. Sometimes it's difficult to understand what is replication, what is caching. And sometimes you need a cache. And there are some specific products for that. We didn't talk about Varnish, but, well, it could be a perfect solution. You have to analyze the life of your data, your TTL. I've seen in the past, I have a million of requests per day, and also for the content that I have to keep alive for 1 minute, with million of requests, you save a lot of time. You save at least 20% of the request across the world. But, okay, if you want, what I can tell you are, okay, split in pieces. I think this is quite simple. And track the version. In this way, you can transfer only what you need on what is changed. And transfer only when you need. Sometimes, well, sometimes it's good to prefetch. Depends of the load that you have. If you have a spike load that retrieve most of the time the same region of data, probably is much better to make a prefetch or pre-warming, but otherwise wait the request. If you are able to use notification, for sure it's much better to invalidate the cache or to notify the change on the data that is replicated somewhere. Move the data close as possible to computation. No, that means you reduce the latency to retrieve the data for computation purpose. Move also the master more close on the user or the who start to use the information. A small trick sometimes is to split the counter or the data. For example, in some cases, if you have some counter and you can split the counter, that speed up the write because the application can choose one of the counter that you reduce the deadlock or anyway the mutex for this information. You will have a slow read because you have to read all the counters, but And if you have applications that are more write-oriented, that give you a very high, big advantage. If you are working on the HTTP, don't forget the E tag and last modify. That's if you use Akamai and so on, they use a lot. And you can make some other tricks, some prediction. For example, if you have a content that have 1 minute of TTL, and you receive in the last 10 seconds of the TTL a request for this content, probably you can ask to the backend through the E tag or last modify if it's changed and make a input for another minute. Because you are so close that perhaps in the next minute some other will be required this content. Also, there are, yeah, that is a small trick to reduce the traffic and try to predict if the content is useful or not, and if you have to keep in the cache. Well, as I said, if you want to write, I wrote a small file system based on most of the things that I said, and it's funny. No, I have to say that it's very funny and it's very nice. You challenge with a lot of problem, in special way when you have to make replication between the two sides of the word. I divide the problem, and well, most of the topics were covered by this talk. In 5 elements, divide the data from the metadata, try to keep in separate element, separate connection, parallel operation, keep track of everything, make compression, reduce the transmission, and so on and so on. That's you can download somewhere. And part of the RESTFS, I probably in a couple of months, I have also a small block data replication on multiple node. Because yes, there are a lot of tools, but a simple tool that you put a block of data and this is spread around doesn't exist. For me, it was useful. Then I wrote that and will be open source quite soon. But you can do the same things. The main concept was okay, hash content, hash base, the placement. I use 0MQ for the transmission protocol. That means you reduce the effort to write your protocol and handle all the connection. I use the GOSSIP protocol to make the election of the node for the replication, or better, to detect the node. And also in this case, you can decide how many elements you want to write or read. This is the last. This is not mine, but I believe it's quite true. And any question?
Just one regarding this NoSQL databases. I was wondering how do you back up and restore such distributed systems in a consistent manner?
Yeah, this is one of the problem. For example, in React, you have the region has two way to work. One is continuously, and one in a certain way is create a snapshot. But yes, sometimes it's a problem to create. Some SQL has a versioning. Then you can freeze to the versioning. No, you have a version of the object. But yeah, that's mainly one of the topics. That's one on long storage retention problem. But yeah, there are also in this case depends of the solution. Each element has different solution, and if you have a versioning, you create snapshot and so on. Others create the snapshot of the metadata, where you have the hash. That's in some cases important to have the metadata database dumped, because the data is on the node and stay for quite a while. And from the metadata information, you can retrieve and create the dump. Others, yes, made the dump for each node, But yeah, the consistency of the data is a problem. Yeah, the versioning mainly is multi-versioning and so on. Should be the best solution, but depends of the database of NoSQL. Someone doesn't have any solution.